I'm developing a full body exercise machine for people who've sustained a spinal cord injury and are paralyzed from the waist down. It's important to exercise after a spinal cord injury to prevent weight gain and to minimize the secondary effects of sitting in a wheelchair all day long. So, unlike current exercise options after a spinal cord injury, the exercise machine that I'm designing enables standing exercise that engages the entire body. For context, on the screen, I've divided existing exercise options after a spinal cord injury into three categories: arm workouts, leg workouts, and motorized standing. Arm workouts typically consist either of free weights or of a roll-up Bowflex style machine, such as the one I've included on the screen. And while upper body exercise is important after a spinal cord injury to build the muscles necessary for manually propelling a wheelchair, it's not the most effective workout because it's not engaging the largest muscles in the body. On the contrary, electrical stimulation leg workouts are targeting the largest muscles of the body using electrical stimulation. The user would roll up to a cycle machine, as shown in the lower left corner, and they would apply the electrodes and they would begin to cycle. The electrical stimulation induces a cyclic motion of the legs that's constrained and resisted by the exercise machine. While this is a more effective workout because it's targeting the larger muscles of the body, the user is still seated in their wheelchair. Which brings me to the third category, which is motorized standing. And while this category allows the user to stand and get out of the wheelchair for a short time, the motorized exoskeleton is doing all the work. So there's very limited actual muscle engagement. So my thesis work is to develop an exercise machine that combines the benefit of all three of these exercise methods into a single machine that allows for standing exercise that is fully muscle powered. So the machine is an exoskeleton as depicted in the center of the screen, and it's a fully passive orthotic brace. It has no motors to assist with standing or walking. Instead, the device is powered by electrical stimulation of the quads, the muscles on the tops of the thighs. Since it's not possible to walk using only the quadriceps, I developed a spring-loaded system that traps and redistributes that energy to do the work of the muscles on the back sides of the legs. And this is important because it's really hard for someone who's paralyzed to apply electrodes to the backs of the legs, so this circumvents that. So the exoskeleton also comes equipped with arm crutches for upper body engagement and to help with stability and balance during the exercise. So this device is currently undergoing the first round of human testing with a volunteer without a spinal cord injury. And the expected benefit of this device is to allow people who are paralyzed from the waist down to do fully standing exercise powered by their own muscles. Thank you.